Hello students, after learning the basics of small g, it's time to learn its mathematical expression. Alright, so I'm going to derive the mathematical expression. It's going to be slightly lengthier. You're going to stick with me, right? So what I'm going to do, let us assume this is the art, and suppose there's an object over here. Alright, let me clear it up. I have to explain something inside the art. Alright, and let's say this is the mass of the object, small m, and let's say the mass of the art is capital M, it's huge, right? So I'm taking capital M for this one. Alright, so now center of the art, this is the body, distance from of the body from the center is this much, isn't it the radius of the art? So let us write capital R for this one. Right, is it clear? Okay, and we know that if the body comes downwards, it will come with acceleration due to gravity small g, isn't it? Alright, so I'm going to skip the introduction part. Obviously you can write this part. So the object with mass m is going downwards with acceleration. What is the acceleration? Small g, positive. It's going downwards. The radius of the art is capital R, and the mass of the art is considered as capital M. So we know from Newton's second law, so the second law, Newton's second law gives us F is equal to ma. So in this case, my mass is m and my acceleration is g. So I have F equal to mg from Newton's second law. Right? It's clear? So let's say this is equation number 1. And from the universal law of gravitation that I have discussed already, universal law of gravitation, the expression for F will be, do you recall the expression? F of g mm by d square, isn't it? So in this case, capital G, capital M, small m, and what is my distance? Capital R, R square, isn't it? So let's say this is equation number 2, right? So if I compare 1 and 2, left hand side F and F. So if I compare 1 and 2, what will have? I'll have mg is equal to g mm by R square. Alright, so m and m are cancelled from both sides. So I have small g equal to gm by R square. So this is the expression for small g. What is capital G? Universal gravitational constant. This I have explained already. What is capital M? Mass of the art. And what is capital R? Radius of the art. So this is how I can find the value of small g. Note one thing over here. In this particular expression, there is no small m, right? The small m gets cancelled. That means the mass of the object doesn't matter while calculating the value of small g, right? So this m is small or large doesn't matter, because there is no in the expression there is no small m, right? There's only capital M and capital R, and obviously capital G is a constant. So small g is equal to capital G m by R square. This is the expression for acceleration due to gravity. In the next video, we are going to find out the value of small g in case of art. Please keep learning.